Hello, ladies and gentlemen. This is Sourobh Kumar Dotto, and I'm going to guide you in IB, IGCSE, ISC, or CBSE mathematics. Today, we are doing a lecture on indefinite integration. I have a special formula for you, which is going to be really helpful. And here, we'll be discussing through this series on indefinite integration the whole of integration. Remember, integration is a very important part of the mathematics that you're studying, which is having applications of this indefinite integration in definite integration, then application of integrals wherein we find the area and the volume of different figures. Further, in differential equations also we use this to find out various curves which have just equations in just one variable or probably more than one variable. So all of this is going to be happening step by step. So make sure you're there with me and you look up the series step by step. Do the sums like I'm telling you, do the practice questions, look up the solutions, and make sure you get full marks in this. So let's get started, children, and let's look up a formula which I want you to look up today. That is integral of any function which has got an algebraic linear function with it. Like suppose we can have e raised to the power ax plus b. So ax plus b is an algebraic expression which is linear, which is attached to some other function. Then we will integrate the function like we normally do. However, we will now also be dividing by the coefficient or the number which is multiplied with x. Obviously, to that the constant of integration is to be added. Now, to understand this more clearly, I have an example. If you have cos of 4x plus 3 dx, remember this is a cos function, so it is going to be integrated just like a cos function, but as along with cos function we also have as the argument or the angle an algebraic function which is a linear function. So by the rule that you studied just now, you should be dividing by the coefficient of x to get to the final answer. And as you can see here, this is just the same like I told you. That is, it'll be equal to sine of 4x plus 3, as the integral of cos x is sine x, right? So we'll have sine of this angle which is 4x plus 3. However, as the coefficient of x is 4, we divide by 4, and to that we add the constant of integration. So this is a formula which you must have looked up in shorts, as all of this that we are discussing is actually the theory that I've already discussed in the short. For better understanding, I'm just repeating it once. Now, if you have a function which is e raised to the power 7x plus 4, you know that this is a function just like e raised to the power x, an exponential function which has the integral e raised to the power x, but because in its exponent there is 7x plus 4, as such we will now be dividing by the coefficient of the linear term, that is 7, and to that then you will add the constant of integration, that is plus c, and that thus is going to become your integral. Now, have you all been able to understand this? How we solve questions on integrals which have an algebraic function attached to some other function? Sure. Very good. Now, children, let's discuss a question which is of this type. Now, initially, like you know, I will give you a little time for trial, and after which I'll be discussing the sum with you people. Now, this time for trial that I'll give you will actually be very short. It'll just be 10 seconds. But I expect you to try this for a longer duration of time using what I've already told you and using what all you've learned all through in this series. So make sure to apply all of that and give this a good try, thinking that you can do it. Because the moment you start thinking that you can do something, you develop confidence, and you are in the rare group of all those people who for a maths sum has some confidence. Otherwise you'll be scared and probably you'll move away. That is not the way. You've got to think that you can, and I'm telling you that you will be able to do it. Start doing something or the other. Use all that you've learned. there'll be a time when you will start solving sums and you will feel very happy about this. Okay, let's go about with this. I want to give you 10 seconds, but you'll be taking a longer duration and giving this a good try. Make sure, children, that you are seated at a place which does not have any disturbance, like any cousins or parents or friends popping by, and you do not have any electronic gadgets like a computer, laptop, a mobile, etc., which is switched on, which disturbs you, right? Put them all away during the time of studies. Okay, now children, now that your 10 seconds has elapsed, I think that you people must have tried the sum out well, right? And now I'm going to discuss the solution of this sum. Now, whenever in such a sort of a sum where you get to see that you have a linear expression, right, and with that is multiplied an irrational algebraic expression, then you're going to try and develop this expression which is within the surd outside, and then you will find that with that there will be a constant which will be left out, and that then can be dealt with pretty easily. Now I'm going to show you all of this now. So let's now discuss the sum. So first thing that I'm going to do is I'm going to write the capital A, which actually represents answer to this question. Okay, now like I told you, we've got to develop the algebraic expression which is within the surd, and you see that that is 2x minus 7. That's definitely not 3x upon 2, right? So that's why this 3 upon 2 is going to be taken out, and when we take out this 3 upon 2 from the first term, right, obviously the first term will become x, and then we will have 7 which will be divided by this 3 upon 2, right? And with that obviously is multiplied this 2x minus 7, which won't change. Now in the next step, what we can do is we still have this 3 upon 2 outside. So inside, children, what we can do is we can develop this 2x by multiplying by 2. Obviously then you will also have to divide by 2, so we divide by 2 and now multiply this expression by 2. So we have 2 which is multiplied with x, and then further we have 7 which is divided by 3, and this 2 which will come over to the numerator on reciprocation, and further as we have multiplied this by 2, so there will be another 2, and all of this expression is multiplied with the surd, which is 2x minus 7, and then obviously we have a dx here, right? So next step, children, what we can do is we can now write this as 3 upon 4, which is outside, and integral of 2x to which is added here. 7 into 2 is 14, 14 into 2 is 28, 28 upon 3, right? And now since you require minus 7 along with the algebraic expression within the surd, right, so as such you will add minus 7, and obviously you will subtract minus 7, that is you will write plus 7. On subtracting minus 7, won't it become plus 7, right? That is why you will do this, so that you can get to 2x minus 7 as is within the irrational term, right? So 2x minus 7 is inside, and we have dx. Remember, all of this is multiplied. That means there are two expressions, one expression which does not have any power in the index, which is a fraction, and another which has a power in the index, which is 1 upon 2, right? So now what we do is we can further write this as 3 upon 4, which is multiplied with 2x minus 7. So this now is exactly the same as what we have within the surd, right? And except that we have two terms which are constants, so we are just to add these two terms, right? And when we add these two terms, it is going to become 7 into 3, which is 21, right? And 21 when added to 28 is going to become equal to 49, right? So we have 49 which is divided by 3, which is the constant which is added to this 2x minus 7, right? So 49 upon 3 is added to this. Now this is a separate entirety, and remember both of these are in multiplication of this third, which is 2x minus 7. Now children, the magic will happen, that is, we will be able to deal with this integral, and just see how. So further, next what we do is we now can multiply this 2x minus 7 with the third, and we can also multiply the third with 49 divided by 3, right? Obviously that can very easily be done because multiplication has the distributive property, right? So applying that here, we will now get 3 upon 4, which still stays outside quietly, right? And that's not disturbing us, so that's a good boy. Okay, now these guys are now going to get multiplied. That is, one is 2x minus 7, which is raised to the power 1, which is going to be multiplied with 2x minus 7, which is raised to the power 1 upon 2, right? And then we have now the multiplication of 49, which is divided by 3, and it is to be multiplied with 2x minus 7, which is raised to the power 1 upon 2 dx. I'm sure the rest of the class must be able to understand now what's going to happen, as now we've been able to get them into integrable formats. Okay, so here thus we now have 3 upon 4 times of integral of 2x minus 7, which is raised to the power 1 plus 1 upon 2, that is 3 upon 2, and then to that is added 49, which is divided by 3 multiplied by 2x minus 7, which is whole raised to the power 1 upon 2 dx. Now children, here you get to see that we have actually 2x minus 7, which is raised to the power 3 upon 2, and if here we multiply this with its derivative, right, we can very easily get the integral of this function. That is another rule that we have yet not discussed, a formula which in times to come we're going to discuss, probably the next one. But at this time, you know that this can now be treated just like x raised to the power n. Remember, the formula is, if you have integration of say some x raised to the power n dx, you know that this becomes equal to x, which is raised to the power n plus 1, which is divided by n plus 1, and to that then the constant of integration is added. This is a very regular formula that we've been using. So now we're going to use this to this expression as well as to this expression, as both of these are now acting as if they're just like x raised to the power n. But we've got to remember that in this x raised to the power n, like in the example that we've looked up, this is actually having an algebraic expression which is linear. So we'll be just dividing by the coefficient of x, and that's it. And then we'll just treat it like x raised to the power n. So as such, now further to integrate, this is going to become 3 upon 4, which is still standing outside quietly. Good boy, right? And then we have 2x minus 7, which is now raised to the power 3 upon 2, to which 1 is to be added after getting integrated. Now this is to be divided by 3 upon 2, to which 1 is to be added, just like the formula we looked up just now. But remember, this also requires, that is, the denominator also requires to be multiplied by the coefficient of x, that is 2, right? Now children, to this is to be added 49, which is divided by 3, right, and is further to be multiplied with 2x minus 7, which is just going to be treated like x raised to the power n, right, raised to the power 1 upon 2, to which you will add 1, just like the formula above, and again you will write this number which is in the index in the denominator also. But remember, as this is a linear expression which has been treated just like x, so whatever is the coefficient of x, that is 2, with that you will divide, and to that then you will add the constant of integration. Now further children, what we do is we will now further simplify this, and that is all that we've got to do. So here we have 3 upon 4, which is now going to be multiplied by 2 2x minus 7, which is raised to the power now 5 upon 2. After taking an LCM, we will have 3 plus 2, that is 5 divided by 2, right? And which is now divided by 2 times of 3 upon 2 plus 1, which again becomes equal to 5 upon 2. So we'll write this as 5 upon 2, where we'll get to see that 5 will actually, 2 will actually now get cancelled with the 2 that we have in the denominator, right? And then to that is going to be added plus 49, which is divided by 3, and then we have 2x minus 7, which is raised to the power 3 upon 2, which is divided by 3 upon 2. And now further we have 2 multiplied with this. As such, again we will have both of these 2's getting cancelled, and then we will close the brace bracket and add c, that is the constant of integration, and that will actually become your final answer. If you want to further simplify this, you can also take the 3 upon 4 inside, then it'll get simplified a little more, although I'll just write this. That is next. Now you can write this 3 upon 4, let's keep it outside, and inside then you will have here 2x minus 7, which is raised to the power 5 upon 2, which is now just divided by 5. To that is added 49 upon 3, which is now multiplied with 2x minus 7 whole raised to the power 3 upon 2 whole divided by 3. Closing the brace bracket and adding c, that, children, will become our final answer, right? So I hope you all are clear about this, but even then I find that there is some bit of confusion which Anna has. I can read it from her facial expression, so I will repeat the whole sum. Moreover, this is something which is customary with me, right? So I normally do a second explanation so that everybody is clear with all that I have taught. So please focus here, and till the time the second explanation doesn't terminate, don't pick up your pen to write this down. Okay, you will have your chance when you will get to do the sum all on your own. That is what I call class work done again, right? And that will really help you in understanding. Moreover, remember that if you're seated on a table and chair, that is a prerequisite of you understanding all of this very nicely, because that is where all the laziness is shunned off, right? When you sit on a table and chair straight, just like me, that is, your spine is neutral but it is straight, right? Then you can keep writing, taking notes, and everything is done without you falling asleep. However, when you try to study on a couch or on a bed, then what happens is gradually you tend to feel lazy. You just put your hand a little distant, because the back aches when you're sitting in that posture, right, of your legs folded and you're trying to sit straight to try and understand. Right, as the back aches, your hand tends to stretch and gradually you fall asleep, and then when you are asleep you have forgotten all work, right? So to avoid it, always sit on a table and chair and study. I'm sure the study is going to be more serious, right? So that's a golden nugget, do follow it. Okay, now if you're not, please sit on a table and chair and then try and understand this, okay? Because after this you have to practice this also, right? Okay, so we have the sum which is there, a linear expression which is multiplied to a third, which within is another linear expression. Whenever you have such a sort of integral, remember all integrals cannot be brought to the final result where we can get to the original function back. That means all functions are not integrable, right? There are only a few which you can bring it in the form of the formulae that you've studied, other ones that you can integrate, others can't be, okay? So in order to try and make this to be integrated, what we do is we try and bring the expression 2x minus 7 outside. Now in order to do that, first what we do is we take this 3 upon 2 outside. From the first term it comes out, but from the second term, as it is not there, so it will be divided, that is 7 is going to be divided by 3 upon 2, right, which will obviously reciprocate and become 7 into 2 divided by 3 in the next step. Now as we require 2x, so we will also multiply it by 2, and when we multiply by 2 here, then what will happen is we'll have 3 upon 2, which is multiplied by 2 in the denominator, and this 2 which is multiplied within the bracket makes it 2x plus 7 upon 3 into 2, which was earlier there, again multiplied by 2. Right, now we are close to getting to 2x minus 7, as we've just got to add minus 7 to it and subtract minus 7, right, because this was not there, so this automatically should get cancelled. That's why we have minus 7 plus 7 here. However, the minus 7 is going to help us out in making the expression which is within the third, and the plus 7 is going to get added to the constant. Now 3 into 7 is 21. 21 when added to 28 will make it 49. As such, we have 49 divided by 3, and except that we have 2x minus 7. Now this 2x minus 7 gets multiplied with this third to make it 2x minus 7 raised to the power 1 multiplied by 2x minus 7 raised to the power 1 upon 2. Remember, if you have root of a, that means the power of a is 1 upon 2. Now next, children, here this rule of indices applies, which I'm sure you people must be knowing. That is, if you talk about a raised to the power m, which gets multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n, right? And as such, here we have applied this rule, and thus we've got 2x minus 7, which is multiplied with 2x minus 1 raised to the power 1 upon 2, so that makes it 1 plus 1 upon 2, that is 3 upon 2. Next, we have 49 upon 3 just getting multiplied with the third, that is 2x minus 7 raised to the power 1 upon 2. And now we integrate both of these separately, right, remembering that the integration of x raised to the power n is actually x raised to the power n plus 1 divided by n plus 1 plus c, right? So as such, we now have here 2x minus 7, which is going to be treated just like x, which is raised to the power 3 upon 2 plus 1 divided by 3 upon 2 plus 1. But since this is a linear expression which is treated just like x raised to the power n, that's why we will be dividing by the coefficient of x, that is 2, right? And here too we do the same, that is 2x minus 1 raised to the power 1 upon 2 is going to be treated like x raised to the power n, right? So that's why we have 2x minus 7 raised to the power 1 upon 2 plus 1 divided by 1 upon 2 plus 1. But since the coefficient of the linear term is 2, that's why you will divide with 2, right? And thus this is the integral. Further, just a little bit of simplification has been done here to get to our final answer. I hope you are clear about this for sure. Really, that's very good, as you've been able to understand now something which you can apply again and again, and I can assure you that this is a very handy formula. Now children, few things which are gifts for you people, as you stayed here till the end. You could have done something else, you could have served something else, but as you have not served something else and you just looked up this lecture and tried to understand this sum, this problem, and make your integration very strong, so I give you some gifts. Now do look out for few links which are there in the description, right? The first link is the one which you'll get for the practice problem, which is underneath here, right? So this is the practice problem for which there is a link, right? When you click on the link, you will get the practice problem, right? You can first try it out, and if you can't, then obviously there you will also find the solution of the sum, right? So this link is going to take you to Google Classroom, where not just you have this question like the practice problem, you will also get this page from where you can copy the sum and then try out the sum all on your own, right? So this page of classwork will be there, except that you will get the practice question, and if you're not able to crack the practice question, as it's a little complicated, so that's why there will also be a solution video, so you can even watch the solution video there. But make sure that after you watch the solution video, you again post the pics of the practice sum done by you, right, in the assignment that is there in the Google Classroom. When you do this regularly, I can assure you, you're going to become a very good student, and that's really going to help you out. If you find that this pace is slow and you want to fasten your pace, you want to quicken your understanding of mathematics, or probably you are interested in learning something else in mathematics, right, like binomial theorem or probably differentiation or whatever, there is a Google form link again in the description of my profile, right? Do click on it, do write what your problem is and a few particulars, your name, your email ID and your telephone number, etc. So then I will provide to you people what you require and make sure that you become perfect in mathematics, right? So let's catch up and let's make this world say mathematics is easy and I can do mathematics, and mathematics really interests me. So bye, this is Sourobh Kumar Dotto signing off, and I'll meet you very often, that is every day, and try and help you in something or the other in mathematics and make your mathematics gradually strong. And you do write to me in comments what you learned in this lecture, how you found this lecture, what else I can do for you. Moreover, do fill the form and tell me what else I can do for you. What are the other topics in which you want strengthening? If you have some doubts, that too you can write there. And do solve the practice problem and send it in, that is, send in your work by clicking your work after doing the work in the Google Classroom link. Okay, bye children, meet you people soon. Bye.